This is your calculus video on section 2.3, which is the precise definition of a limit. So personally, I just want to encourage you to take it to the limit personally. So try to reach your Mach 10, whatever that means for you. So your first objective in here is to solve problems involving centering intervals about a point. Your next one, finding deltas graphically and algebraically and using the formal definition. So why we're studying this is for the precise definition. This will allow us to replace vague phrases like gets arbitrarily close to, it's near, or anything like that in the informal definition with specific conditions that can be applied to any particular example. So with a rigorous definition, we can improve communication, basically, avoid misunderstandings, prove the limit properties given in the preceding section, and establish many important limits. So to start with, you can think of the definition as a quarrel between a skeptic and a scholar. The skeptic says there's epsilon challenges. Now, what you will need to remember is that epsilon has to do with the y variable, and similar to the L variable limit, to show there's room for doubt that the limit even exists. But the scholar actually says, or the lawyer, counters every challenge with a delta interval. So that's delta, which has to do with x, which has to do with the c variable, which ensures that the function takes values within epsilon of L. Okay, so here I'm going to show the picture of it. So the skeptic says, well, what if it's above or below? Then the scholar would say, well, then the x is going to be either above or below. And it's the same thing here. You know, what if the limit is above or below? Then the, x would be, to the right or left, basically. So what you need to just take away from this is that x, c, and delta have to do with the horizontal, and L, epsilon, and f of x, or y, have to do with the vertical. So epsilon had to do with the vertical, and delta had to do with the horizontal. That will help when you start writing your formula and everything. Okay, so then on the next part, it says let f of x be on an open interval about c, except possibly at c itself. We say the limit of f of x as x approaches c is the number L, and write f of x's limit as x approaches c is L. If for every epsilon that's bigger than 0, there is a corresponding delta greater than 0, such that your absolute value f of x minus L is less than epsilon. So these are the ones with your vertical parts whenever your horizontal parts have a condition. Your 0 less than x minus c less than delta. So for testing the formal definition, it doesn't tell us how to find the limit, but it does verify that a conjectured limit is correct. So it basically just lets you test it. The real purpose is not to do calculations, but to prove the general theorems. So your specific limit calculations can be simplified. So then it says see page 58. So on 58, the challenge is to make epsilons equal to 1/10. And so that means to make it go up 1/10 and down 1/10. So then the response would be delta of that number. So delta of 1/10 and delta, it's basically subtracting. And same thing here. I'm just going to go to the responses. So if this goes up 1/100th and down 1/100th, then this has a delta corresponding to the 1/100th, and going to the left corresponding to the 1/100th. And same thing as you have more zeros with 1,000, 100,000, and so forth. And on the last one, they just have the ... So what you would notice is your yellow rectangle for up and down, and your blue rectangle for the horizontal part, going right and left a certain amount, gets smaller and smaller as you have more zeros in your denominator. Because that's actually good, because that's what you want. So basically compare 0.01 to 0.00001. Just the more zeros, the more accurate, whether it's above or below a certain amount. If it's below, then you'd have like 0.99 compared to 0.99999, things to that nature. So when the interval is not symmetric, we can take delta to be the distance to be closer to the nearer endpoint. So basically, you're going to subtract on both and see which one is smaller. Subtract and use the smaller value. On this part, it says solve the inequality. In other words, solve the inequality with the absolute value f of x minus L less than epsilon to find an open interval AB which contains C, which means it has to be in the order A, C, B, for where the inequality holds for every x that is not exactly C. Notice we don't require it to be equal at C. It may or may not, but it doesn't influence the existence of a limit. So like before, we did things like, oh, there's a V graph, here's a little circle, and there's the other part. So the limit exists since it's the same value from the left and right, even though the point doesn't exist. So, and that's what we're kind of still doing. We're just improving on that. So we want to find the value of delta being greater than 0 to place it on an interval so that you have plus and minus the same amount, so it's centered. And that inequality will be affected for the f of x minus L. Okay, now it says see examples on page 59 and 60. So this is where you actually start doing your math part of it. just going to move this for a second. Okay, so it says solve your, well, first let's make sure we read it. The limit x approaches 5, so that means c is 5. And then the square root of x minus 1 would actually be your function. And the 2 would be the limit, so that's the L. And it says find a delta that works for epsilon equal 1. So then in your absolute value symbol, remember it's f of x minus L. And so that's the square root of x minus 1 and then minus 2. And then you want it for epsilon equal 1, so we have less than 1. So that's your first part, because that's the f of x minus L less than epsilon. And this is the part where it's 0 less than x minus c, which in this case is 5, less than delta. So then you have to do your inequality parts. It's an absolute value less than 1, which means you have a negative 1 here, positive 1 here, have it in the middle, without your absolute value symbol now. So that step just means break it into a positive and negative, and then you add 2 to this side. 2 minus 1 is 1. Add 2 to this side. 2 plus 1 is 3. Then you're going to need to square both sides. Like you square the middle to just take off the square root symbol. And 1 squared is still 1. 3 squared is 9. And then you got to add 1 to both sides. So you get 2 and 10. Now, after that, there's a, well, that's your interval, but after that, there's a step. It says it will place it between 2 and 10, which implies this, where it's 3. Now, on the picture, there's your 2 and 10, and so since our answer was 3, you go 5 minus 2, it's 3, then you go 5 plus 3 is 8. So in other words, 5 was closer to 2 than it was 10. So that's what we wanted. And then we also said go through example 5. So this one's a piecewise function. Prove that the limit is 4 if you have x squared if it's not 2, but 1 if it is 2. So that's single point 2, 1. So you start with saying f of x minus 4, because that's our limit, less than epsilon, whenever 0 less than x minus 2, because that's our c, is less than delta. So then we start working this and trap the function basically between negative epsilon and positive, and then just start solving. So we add 4 to both sides, they put it 4 in front, and same thing here. Then this step may look a little weird, but they're saying take your square root of x squared and it's going to be the absolute value of x, and then they just assume that it's going to be positive, because if our limit is 2, then it will be positive. And then they want you to find the minimum between these. So the minimum number is the one that we would want. So f of x minus 4, that absolute value is less than epsilon whenever 0 is less than x minus 2 less than delta. Okay, so that's basically your notes on it, and then the next part was using the definition to prove your theorems. We don't usually rely on the formal definition to verify it. Rather, we do our general theorems and then test it. So to solve some problems, you want to look at C and then do the absolute value C minus A and the absolute value of c minus b, and then choose the smallest. And then use f of x minus L less than epsilon. Substitute and solve the inequality. The answer a less than x less than b has the answer for the interval like AB. Then again do a minus b, or c minus a and c minus b, and get the smallest. So pretty similar to that. Okay, so let's actually show some examples now. So on the first one, there's your paragraph basically, and you're given your A, B, and C. So if we just graph it on a number line, 10 would be here, and that's A. 22 would be there, and that's B. And then 17 would be kind of closer to the B in this case. So what you want to do is 17 minus 10, and you get 7. 22 minus 17, and you get 5. 5 is smaller, so that's your answer. That's all it is. Okay, so on this one, you have negative 5/6 here, and then that's the A. The B is the negative 5/7, and then the C is going to be somewhere between at negative 3/4. What I would do, I know that we might want to get the decimal equivalent just to make it a little bit easier to see. Negative 5/6 is like negative 0.83 repeat. Negative 3/4 we know is negative 0.75, and negative 5/7 is negative 0.714. So that'll help you if you don't like fractions. Just know that you have to be going left to right, so C has to be in the middle. So what we want to do is basically, like this one was C minus A for both of them. So when we do C minus A, we're going to do negative 3/4 minus a negative 5/6, which is actually plus. And then we're going to do the other end where it was B minus C. So B minus C. So that would be negative 5/7 minus a negative 3/4. Okay, let's compute those two fractions. Negative 3/4 plus 5/6 is 1/12. And just for understanding, that's about 0.083 repeat. On the other end, we have negative 5/7 plus 3/4. So that's 1/28, which is pretty small, and that is 0.0357. So then you pick your smaller one, which is this. That's the smaller between 1/12 and 1/28, and so that's why this answer is 1/28. So then you just have to pick your correct number line graph. Negative 3/4 should be in the middle as C. Okay, this one's definitely not it. Yeah. And then the difference between these two graphs is this one's going from -1 to 0, and this is actually doing what we wanted. The negative 5/6 is A, the negative 5/7 is B, and we already put C for the negative 3/4. So that's basically what we do. Do the same thing here. We want number line A here, C here, B is, I'm sorry, A here, B here, C is somewhere in the middle. So this is -1/2, -1/3, -1/4. So then you do your C minus A. So -1/3 minus a negative, or just plus 1/2. And on this one we do B minus C. So -1/4 plus 1/3. So -1/3 plus 1/2, that gives you 1/6, which is about 0.17, and -1/4 plus 1/3, whoops, that's the 1/12, which is like 0.083 repeat. So again, after you do that, you want the smallest one, which is 1/12. Remember that the bigger the denominator, the smaller it is. Because if you have, I mean, just think about it, sharing food. Like share a circle, like share a pizza. 6 slices are going to be bigger than 12 slices. That's how you can think of it. 6 slices are larger than 12 slices of pizza. We say you have 1 pizza, that's your numerator. Okay, and then you just pick your correct graph with the A, the C, and the B. So lots of easy ones to start with. On this one, choose your correct graph, and this is the A, this is the C, this is the B. And then the only difference is on this one you're doing decimal form. So since C is in the middle, remember we do C minus A, and on this one we do B minus C. So this would end up being 2 minus 1.7326, and this would be 2.2821 minus 2, which you don't have to type because you know it's just the decimal part. We do need to subtract this. 2 minus 1.7326. That's your 0.2674. And so that number is smaller than that one. And so that's your answer. So always choose the smallest between C minus A and B minus C. Don't get confused on the largest possible value. I mean, y'all have been seeing that the math is really easy, but this part right here confuses you, or at least it confuses some people. The largest possible value is the smallest value. So don't let that throw you off. It's weird. I don't like it. It's just take it out. I mean, basically, you need a valid value, and the smallest one is the valid value. Okay, so now for this one, we want to do the same type thing with your formulas. I think we usually start with f of x minus L less than epsilon, and 0 less than x minus c less than delta. So do we know our function name? Yeah, it's right there. It's square root of x. And do we know our L? Yes, it's 1. Do we know our epsilon? Yes, it's 1/6. So some of y'all may want to actually just start out this way, where you say negative 1/6 less than square root of x minus 1 less than 1/6. A couple of quick things. Don't extend the square root value, because the 1 was from the limit. But that's where you may want to start, and then you want to add 1 to both sides. So this is 5/6, and add 1 to this side, so that's 7/6. So that really is like 1/6 apart. And then we want to square both, and so you get 25/36, and square, when I say square both, I mean square the numerator and denominator. So then you have that. And that does end up like right here. Now let's just do our 1 minus 25/36, and then do 49/36 minus 1. Let's see how we go. And this is 11/36, which is about 0.305 repeat. And this one's 13/36, which is about 0.361 repeat. So this is the part for that. And again, you want to choose your smallest. So that's our delta. Choose the smallest, and that's your answer. Okay, on this one, we want to do our same type thing. If I like start to abbreviate it, students would probably say put negative epsilon first. So like put negative 0.5 less than 4 over square root of negative x minus your limit, which is 4, and then put 0.5 here. So we're going to add 4 to both sides. So you get 3.5 less than 4 over square root of negative x less than 4.5. Okay, now here's the weird math mojo. So it's a lot easier to work with your square root if it's in the numerator. And so let's just say do the reciprocal of everything. Now the reason is because again, we can't work with square roots. Like if you multiply by a square root to the numerator, you do it here and here, and that's weird. So we just want to say 1 over 3.5, and then this is the square root of negative x over 4, square root of 1 over 4.5. Now, how we're able to do that is just like, well, if I add to this one, then it cancels, and then I have to add to this one and this one. So in the same way, if I do the reciprocal to the middle, then I need to do the reciprocal to this one and that one. Now, I wouldn't actually work out your value yet because we've got to multiply by 4. So that would make this 4 over 3.5. This is 4 over 4.5. Then you'd want to square both and then basically just change it to positive. Now, on these, the graph kind of gives it away. I mean, this is the process, but I know you're basically going to say, well, subtract here and see what you get. I mean, it's basically what we're going to end up doing if you want the really quick approach. 4 over 3.5 squared less than x less than 4 over 4.5 squared. Four over 3.5 squared is 1.31, basically. Well, yeah, that's fine. And then 4 over 4.5 squared is 0.79. Okay, that one, I typed it incorrect in the calculator, but of course this had to happen. With the number bigger in the denominator, it's going to be a smaller answer, and so now it's no longer like in the right order, which is weird. So I guess we got to reverse it. Okay, on this one, it's like 16 over 12.25. On this one, it's 16 over 4.5 squared is 20.25. And this one's bigger. So basically, we just have to like reverse these. Okay, I guess I need to put my x in there. So let's try just doing the simple part of the math. I mean, this was what we were supposed to be doing, but it didn't really help us too much. So if we do C minus A, we do B minus C, what do we get? So this would be -1 plus 64 over 49. And on this one, we would get -64 over 81 minus a -1, which is +1. So this gives you 15 over 49, which is about 0.31. -64 over 81 plus 1. This gives you 17 over 81, which is about 0.21. And so 0.21 is the smaller one. So yeah, this is the good process, because this part didn't really help us too much. I mean, it does tell you your delta. Sorry, I said that wrong. Your plus epsilon and your minus epsilon. It tells you that. And then you got to pick your delta. So do you want this part or that part? Okay. So let's just simplify this next one. Do this and see which one's smaller. -1 plus 36 over 25, and then negative 36 over 49 plus 1. Just do that. This gives you 0.44 because that was 11/25. Whoops, that was the other one. No, that was right. And then negative 36 over 49 plus 1. That's 13 over 49, which is 0.265. They want you to round to 2 decimal places, so we make that 0.27. That's it. Okay, then on this one, this is the start of one that's a little bit harder, but it's not that bad. You basically are going to center your value between there. So you're going to go a little in front and a little below. Now make sure your sign is right. Because sometimes you might have a negative here, and so that means your interval has to be negative. If C is negative, then your interval should be negative. Just remember that from the past. Okay, so let's do our computation. We have f of x, which is 7x minus 2, no, plus 2, dang it, and then minus 37 less than epsilon. So we can actually just start doing our math. If this is 0.28, then we can say negative 0.28 less than absolute value. We take out the absolute value. 7x minus 35 less than positive 0.28. And then just go from there. So if you do 35 minus 0.28, I get 34.72, and if you add, you get 35.28. Then you're going to want to divide by 7. So this is 4.96, and 35.28 divided by 7 is 5.04. And so that's the values that are used right there and there. Okay, and then you notice your C was 5, and so if you do 5 minus 4.96, you get 0.04. Or if you did 5.04 minus 5, you also get 0.04. Okay, so that's pretty good length of that video. I hope that helps.